Hello, sir.
Yeah, yes, Gopi.
Sir, at last class, did you conduct any quiz, sir?
Last class?
Sir, last week.
Just a minute. I think you're not audible properly for me. Just a minute.
1 minute.
Yeah, yes, Gopi, yes. Yes, Gopi, what is your doubt?
At last class,
Hmm.
did you conduct any quiz?
Quiz
Quiz, quiz.
we yes, yes. Actually, we are lagging two sessions, no? Quiz today we will be having quiz on SQL.
Last week, sir, did you conduct any quiz last week?
Last week we had, yes.
Okay. I think last week Saturday, I think we conducted a quiz. I think
So what is that issue? Like we have to go with the quiz.
last week Sunday I didn't attend to that quiz, sir. Actually, because of last week Sunday we have class. That's why I
Hmm.
didn't attend to that quiz.
No, that's fine. No, I mean, that is just for your practice. It does not accounts. It does not take care of your marks and everything. That is not associated with that, no?
That means actually in quiz we have to score 75%, right? Minimum 75%, right?
Okay. You can ask to coordinator. That is not very strict. Don't worry about that. Yeah?
Okay, sir. Okay, sir. Okay, sir.
Yeah. We'll wait for 1 or 2 more minutes and then we'll start. Okay, all right. Good morning, everyone.
Good morning, Vipul.
Yes, good morning.
Good morning,
So,
Vipul.
yes, good morning, good morning. So, what was the last topic that we have discussed?
We have discussed on SQL theories, people.
Running data warehouse.
Factorials, warehouse, yeah.
Mm.
Okay, just a minute. Let's continue with that. Uh, let's continue from that discussion only. I'll just take out that Excel file. Okay, so this is what we have, right? So we have started with star schema, I think, and we have completed star schema. Now it's time to understand the difference between OLAP, that is online analytical processing, and online transactional processing. So OLAP versus OLTP, right? All right, so now that you have developed a fair understanding of databases, you might be wondering how a data warehouse and database differ from each other, right? How database and data warehouse differ from each other. So in this segment, you'll learn exactly which features of a data warehouse differentiate it from a regular database. And we are going to talk about the difference between transactional database and a data warehouse. So as I told, there is very vexing question like what is the difference between data warehouse and database, right? But that question is wrong to ask itself. Why it is wrong? Because that is what we are going to discuss, right? Database and data warehouse. It's the difference between database and data warehouse is uh, is a wrong question to ask, right? So to just take that out, we'll just write down over here online analytical processing. This is known as OLAP, and we have OLTP, which is online only transactional. This is related to transactional databases, transactional processing, online analytical transactional processing, right? Okay. So what we'll do is we'll create a table. I'll tell you why that is a wrong question to ask. The reason is database is nothing but a collection of data, right? And so is the data warehouse. Data warehouse is also a collection of data. So more appropriate question to ask would be, what is the difference between data warehouse and transactional database, right? Data warehouse and transactional databases, right? So let me define this term called transactional database by taking the example of e-commerce. For example, Flipkart and Amazon's of the world. So the normal purchases that you do on the website, what you do, you log in, you search for your product, you add it to the cart, and then you connect to the payment system, and then you make your payments, right? Enter your OTP, and this whole thing requires some kind of database, isn't it? So that database is called this database is called transactional database. So consider this Flipkart, Amazon, their databases, right? And the most familiar, that is the most familiar database that we are all used to. So probably that's what you mean when you say what is the difference between a data warehouse and database. So I'm assuming when you say database, you mean this kind of transactional database, right? Which means any database that helps me carry out, say, automation of activities. If it is banking system, I can be using my card in the ATM machine. So that is a transaction that requires a transactional database, which means transactional database are those databases which help carry no users which help carry no users carry out their day-to-day business transaction, whatever that might be, whatever that domain might be. So let us now try to contrast it with the data warehouse, right? Let me check my mic. Is it? Yeah, I think it is good. Okay. So when it compares to data warehouse, so the data warehouse is intended for completely different purpose, right? Transactional database, it is intended for carrying out the business transactions, whereas data warehouse is also a database, but it is intended for carrying out analysis, analytics, and decision making, right? So the end user is completely a different. So to just uh, write down this in the form of a table, what we'll do is we'll write down transactional database, and we'll write down data warehouse, right? Okay. Let's take this, and we'll just take this data warehouse, right? And let's maximize this a little bit. So we can maximize from this. I have no exposure of using Google Sheets, so that's why it is happening. Anyway, so the first point is, this is a myth. You should not use Google Sheet. Excel is the ultimate tool that we should use. See, the first is to perform business transactions. The purpose is for transactional database, the purpose is to perform business transaction, right? Here, the purpose is different. We need to conduct analysis and decision making, right? Then for end user, we are going to talk about the end user now. So we can distinguish both of them from multiple dimensions. Let us try to distinguish it from the user's perspective, which we have done. Who are uh, different type of users who use a transactional database are on the business. It is related to business transactional or transactions. Uh, uh, the people who are actually doing transactions, and the data warehouse, it's a database where transactional database is used by end users like you and me who want to carry out some business transactions online, right? On the other hand, a data warehouse is used by decision makers, by managers. So typically, CEO, CXO, or even it is more for decision making. In fact, those kind of decision are systems where you used to be called as DSS, decision support system, as opposed to MIS, or management information system, or just information system, right? So users will write down, and second point is, this will be a second point, but for that we have first point as end users. These are for business transactions, and here it is used by managers, CEOs, CXOs for decision making. right? Now coming towards the technology stack that we are going to discuss now. So here, if you want to go deeper, we can begin distinguish on the technical side. So let me tell about the similarities. So in both the cases, you have some kind of a server ecosystem that's there to support the system. So if it is a decision support system or analytics system in a data warehouse, or if it is transactional database, in both cases, there are databases. So the similarity is there, right? In both the cases, there are some database management system software that is running for managing the data. In terms of technology, right there are additional moving parts when it comes to the data warehouse. If you recall the discussion we had on the database architecture, largely, so one very significant component of a data warehouse architecture is the ETL process, extract, transform, and load process, which we are going to discuss after some time. Because as part of the definition of the data warehouse itself, one of the key terms is that it is integrated. What we mean by integrated is we expect the data warehouse to contain data from multiple sources, from multiple departments, from multiple other databases, right? So in order to make that happen, ETL is a very significant element of a data warehouse, which finds no place in a transactional database. In the transactional database, you have the DBMS, you have the other side of server side applications, no APIs and application servers, no JBoss server. And so on the technology stack, it is quite different when it comes to transactional database compared to data warehouse database, right? So the key difference is even at the server level is that offer there's no ETL present in data warehouse infrastructure. You don't have to you don't have any ETL that is happening for a transactional database, right? So that is the second difference for you. So we'll write on that. First point here, we don't have ETL process for transactional database. Second, DBMS we have, database management system. And third is server side application. Service side application. Service side application. You can call it as API. And here we have ETL process. So data warehouse architecture is integrated. We have multiple sources. We have multiple databases, and we have multiple departments. Right? That is what you have over there. Now, in the front end technology side, in the front end technologies side, what do we have is okay. Let's move to let's move the stack a little bit. So we did talk about the end users, the kind of technology that are used in front end, and let us talk about the front end. It is called the database itself as the back end. On the front end, if you're looking at it as at the transactional database, right? So the kind of technologies that are used, or web servers or browsers for interaction, mobile phones, and interfaces with payment gateways, payment systems, right? So a lot of transactional front ends are there for my transactional databases. For the database warehouse database, the front end is essentially only what you be known as the BI tools, which is known as business intelligence tool, which means it contains a lot of reporting tools. So you will be having tools like Cognos that's running there. You will be having tools like Tableau. You'll have many reporting front end infrastructure, because the intention of the data warehouse database is not to support business transaction. The intention is to support analysis, So we have BI tools like the reporting tools which add values to the information that is stored in the data warehouse database. So I can do lots of analysis. I can do drill down. I can do roll up. Those kind of operations can be done on a data warehouse database using the business intelligence front end. Whereas transactional database, we generally don't have any such front ends, right? Lot of interacting reporting is generally not available on a transactional database. At the most of at the most, you may be having some called canned report. I mean, it can generate an inventory report of my products in my shelf. For example, uh, beyond that, there is no much of analytics that is going on. So even the technology stack is kind of different from a data warehouse database versus a transactional database. Now, I want to reiterate, in both cases, we should call them as database. Only say, don't ever ask the questions, what is the difference between data warehouse and database in the question. To ask is the difference between transactional database and the data warehouse database, right? So we'll just write down this quickly. This point, front-end technology stack. We have web servers on, then we have browsers for interaction. Then we have mobile phones. And last, we have interface with payment gateways and payment systems. Here we have business intelligence tools, BI tools. So we have Cognos, we have Tableau, we have reporting front end infrastructure, right? That's what we have. So coming towards the next point, which is database design. So last thing I wanted to talk about is the design of a particular database, right? So we'll add last point, database design, and we'll discuss this. So for those who are familiar with database design, the transactional database is generally designed keeping in mind, lots of integrity issues and normalization. So these are the kind of different kinds of consideration that goes into the design itself. On the other hand, the data warehouse database is designed based on, for example, dimensional modeling, right? So in dimensional modeling, the nature of the schema, uh, we use the term called as star schema. You don't create star schema in a transactional database, right? You create star schema in the data warehouse database here. So the way database itself is designed is very different, which means in terms of the usage, the different technical difference in this design is there because the nature of access in a transactional database, it includes all operations. You add new data, you modify existing data, you delete existing data, and of course, you retrieve existing data, right? And this we refer to in database parlance as the CRUD operation: create, retrieve, update, and delete. So in order to write this, we'll write down first point as based on integrity issues and normalization. Second is we don't have star schema. Here, based on dimensional modeling. Second, we have creation of star schema over here. Creation of star schema, right? And this is also known as OLTP, which is known as Online Transactional Processing System. Transactional Processing System. And here it is known as Online Analytical Processing System, right? OLAP, Online Analytical Processing System. So that is OLAP and OLTP for you. So in the data warehouse, you generally don't uh, do all these operations. The focus is primarily on retrieving, because it is not, if it is not transactional in nature, I don't want to log in, right? I don't want to log in into data warehouse database to purchase a product, right? You log in the transaction system over here, right? So given that there is a significant difference in the way you approach working with the data warehouse as opposed to the working with the transactional database, to summarize broadly, the transactional systems are referred to as OLTP. This is referred to as OLAP. So that is a one way to remember the difference between transactional database and data warehouse database. So this summarizes your entire discussion of your difference between transactional database and data warehouse database, right? I hope this is clear for you, so that we can go to the next part now. Is it clear, guys? Okay, excellent. Now, I'll give you some additional resources that you can read about this thing, about this OLAP versus OLTP. From There's one article by Databricks. We'll just search for that. OLTP versus OLAP. Even though it is not required for you as part of a data scientist or machine learning engineer, those who are interested for data engineering role, they can go deep for this particular model. So the article is by Data Warehouse for you.info. Data Warehouse for you.info. I think this is that particular thing. Not exactly this. That is fine. Okay, this is good. So this is what we have. You can take this over here, right? I'll share this on the chat itself so that you can have a look. And as far as another topic is concerned, data warehousing concept is also something you can read. I'll share that link afterwards. Let's go to SETL now, next part. So in our syllabus, we have one important thing which is known as select, extract, transform, load. So I am slipping an extra S over here. It is only known as ETL, extract, transform, and load, but select is equally important for us, right? So I'm slipping an extra S over there, which is SETL. Now let us spend some time trying to understand the life cycle of analytics application. Whenever we want to analyze data, we are more often than not working with data from multiple data sources. There could be an inventory application, which is one data source. There could be another application which is giving me my live sales information, right? That could be another, there could be another data source, and so on. So we could be dealing with multiple data sources which you want to use as a part of your analysis. But it turns out that you cannot take all that data in this multiple data sources directly for your analysis, right? So what we'll do is we'll just create a diagram for a database. Database number 1, database number 2, database number 3, and so on, right? We have n number of databases in our system. So I'm just adding quite a few, which is DB1, DB2, DB2, DB3, and DB4, right? Okay. So we could be dealing with multiple data sources, as obvious. So, which is why we try to draw a line and say that the data sources are all there on one side over here, and I want to get my data for my analytics information, right? On the right hand side, which is typically be called as data warehouse. So on the very extreme right hand side, we have a data warehouse, right? It can be viewed as a collection of an integrated collection or an integrated collection of data that is amenable for our analysis. As I was saying, it is very difficult to take data sources from this data sources and move them into my data warehouse. So what we generally do is we put it through a specific set of processes, which I will be abbreviated. I'll abbreviate it as ETL. But as I told that this will be SETL. It stands for select, extract, transform, and load. So this is generally also referred to as ETL process, but I slipped in an extra S there, and I'll explain what that means. So what we are now saying is that these data sources go through this ETL process before it ends up into data warehouse, and then you can start your analysis, right? So let us quickly look at what this four terms stand for. S, E, T, and L. S stands for select. The current inventory levels, we are selecting the current inventory levels of only these categories of data. I can say that from my sales data source, I need to extract the sales information of only this category of data, this particular category of data. So what we are trying to say here is, for our analysis, we may need not be needing all the data from all the data sources. So the select stage of the ETL process is just the paper identification of what data you need from each of those data sources. Of course, in practice, it is a lot more complicated than just merely writing it down on paper, because in a typical large enterprise, you may have to contact owners of those data sources. You may have to convince them to share that particular data for your analysis, and you have to work with their IT team to figure out how they are going to send your data. Will they be sending it through FTP or whatever mechanism, right? That's very complicated process, but it has to be done. So I have simplified it, saying select is nothing but identification of the data that you want to analyze. Identification of the data that you want to analyze. Right? Then comes to extract process of actually connecting to that particular data source and pulling out the data for your further processing. So for example, we have identified that from the inventory management database, I want the inventory information for one specific category called as electronics. So that is the identification part. But now on a day-to-day basis, for example, I need to connect to the inventory database. I need to identify the inventory levels of that particular electronics category data. I had to extract it. So this process is something that we have to do on a periodic basis. Typically, this is done on a daily basis, right? So we have to keep extracting that particular data. Well, you might be wondering, so we have extracted the data. We have extracted the data. The what is stopping me from jumping into analysis, right? We just have extracted the data. What is stopping me from jumping into analysis? So what we say is data that we have extracted may not be readily amenable for our analysis. For example, it might contain a lot of abbreviations. It might be having currency data in some different currency, and you want to analyze it in a different currency. Maybe the source data is in uh, Indian rupees, and you want to analyze it in US dollars. So you want to transform this into US dollar. So when the data is not readily usable after extraction, we will put it through the next stage, which is called as transform. and it is nothing but modifying the extracted data for various reasons, right? So the modification can be currency conversion, for example, or to standardize my data, for example. The names of cities might have been abbreviated in different ways or split in many different ways, and so we may want to have them spelled uniformly. So that is the transformation, and that is the transformation for it. So to write down some points for this, we can write down modifying the extracted data for various reasons, right? That reason can be anything. Everyone knows this, right? We have to transform our data, which we have done in Python as well, right? So that is your transformation. And finally, the time which is called as load, we say that, right? And I'm happy with the transformation I have done to the data. I have extracted all the data I want. I have made all the necessary transformation that I want. Once I'm getting ready to load the data, and that is when I push my data and change to my data warehouse. So here we load the data into data warehouse. So this is in a nutshell is the select, extract, transform, and load process, which almost always precede the data warehouse analysis. And I should also tell you that it can be as complicated as I told you about picking up the phone, getting into an agreement, and so on. It might be as simple as just receiving an Excel file over the email for you. So the extraction part is a logical activity, and depending upon the data that you are working with, and depending upon the environment that you are working with, it may be coming up in different shapes and forms. Similarly, the transformation activity as well can happen in many different ways, right? As I said, if the if it is the data, if the data is being received by you in Excel, then you may want probably be writing a whole bunch of Excel formulae to transform the data, to uh, message the data with the form, massage the data in the form that you want, right? On the other hand, if you are using any other tool, um, no, there are many transformation tools that are available. For example, Pentaho got a tool called as Spoon. Tableau got a tool called Tableau Prep. So there are many such tools which you can use to transform the particular data. And finally, the load as well on the right hand side. What have shown as a data warehouse again can take many different forms, right? So it can take the form of another Excel file. Fair enough. I can take that file, load into Tableau, load into Tableau, and do lots of analysis, which you are probably done already, right? On the other hand, we are also be imagining that right hand side is an SQL database. So if you are loading that particular database into relational SQL database, then we can fire a lot of queries, analysis queries using SQL. So that is the select, extract, transform, and load process for you. SQL queries for analysis. I hope this is clear for you now, everyone. SCTL. So load is known as pushing the data into data warehouse, right? In this way, you have understood the SCTL, and in the upcoming segment, you'll understand the various constraints now. So actually, now we are building our foundation of what is known as SQL, right? So most of the guys, or most of you, if you go anywhere or if you go to YouTube, they'll start your learning from this point itself. They'll skip this point: data warehouse, structure of a data warehouse, star schema, OLAP, SCTL. They'll directly go to S constraint, and they'll directly start explaining this point: select star from that particular table, right? But I think this should not be the case, because we should understand why we are learning this SQL, right? It's not just like writing down the queries and getting the result. That can be done by any programmer, right? But we should understand why there is a need of database and what kind of thing we actually are achieving by using SQL, right? So for that reason, we should know this 4 to 5 concept beforehand, right? Now, just give me a minute. I'll have a sip of water. Okay. So, okay. Now we are good to go for your constraints. So, majorly, there are three types of constraint to be precise. We have entity constraint, we have referential constraint, and we have semantic constraint. So there are three types of constraint that we have. Many of you, I'm sure you would be having an idea about this, but this is just a fancy word. But you guys know primary key, foreign key, you guys know uh, different constant that we can put for our database, right? But let us discuss this in a more technical sense. You have already learned about ACTL process, which is used to ingest data into schema and perform operations on it. But can we add just any value that we want to a schema, or there are any constraint to maintain the sanctity of the database schema? Put yourself in the place of data analyst, let's say at Uber or any taxi services. So a database at Uber has several tables, right? Which record several details, such as details on the rider, the driver, the vehicle used, right? And transaction details. Each such table has several related attributes which describe it in detail. Consider the rider table. You go through the values entered in a column that contains the fares for each ride. It would be right for you to expect that the fares can have a maximum 4 digit, a far more than even, right? A 5,000, if it is a fare, would raise your concern within a city, right? I'm not talking about the intercity. Uh, Sorry, intracity. So this is definitely an outlier, right? 5,000 fare for traveling within a city, let's say in Chennai or Bangalore. So it will be a very you will be very surprised to get this bill, right? So this is definitely an outlier and needs to be replaced with the right value. Ensuring that you implement the right constant or the right attribute in a table can help you avoid such fallacies. So you'll learn about the relational data model now. So first constraint that we are going to discuss is the entity constraint. This one. So let us write down that entity constraint. Right? Now let us spend some time trying to understand how do you design relational databases. Before we understand how to design the relational databases, we have to understand the concept that goes behind the design of it, relational databases, right? And that I call as the relational data model, right? So you think of a model as a vocabulary or a collection of operations that help me design that particular database using a specific data tool. So the data model that we will be using is called the relational database or relational data model, which is supported by lots of relational databases products such as MySQL, Microsoft SQL Server, we have Oracle, and we have IBM ka DB2. And all these are called relational database management system because they all understand their relational data model, which is why even we have to understand what is the relational data model if you have to work with relational database management system. So let us see what is uh, what are the elements of the vocabulary of a relational model. The first is the data is organized in the form of tables and columns. This is very similar if you are familiar with Excel, right? So just like in Excel, we have these cells that are there, and then we have the rows and columns. So these are also in the relational data model. We call it as a table. So we can have, for example, a table called employee, and we can say that there are lots of attributes or columns associated with their employee table. For example, I can have employee ID, the name of the employees, and the age of the employees, and so on. And these all are referred to as attributes or column. You can clearly see that the columns are actually vertically positioned and the data itself is organized in the form of rows, right? So there are information about 100 employees that are being captured that will appear as 100 rows, exactly like you would see in Excel, right? So in a relational data model, we have tables and column. And let me create a sample table for us, which is employee ID, name, and age. So we can have 1,000 employees actually in this table. Yes or no? Then we have another table, which is, let's say we have department table. In that we have department ID, name, and address. Yes or no? So now we have department ID, we have name of the department, and we have address. Now, as I have discussed, the relational data model, to be more precise, let us give heading as relational data model for this. And let us get small. That's 45. X control B. Okay. So for my relational data model, what do I require is tables. First point, that is columns and rows. Second point is constraints. And in that constraints that I've discussed, we have this three constraint, which is entity, referential, and semantic constraint. So as you learn in the video, constraint are the rules that are used in MySQL to restrict the values that can be stored in the columns of a database. And this basically ensures the data integrity, which is nothing but the accuracy and consistency of the data stored in the database. Now let us continue our discussion on the relational model. So, okay, let's put some rules behind what data can go inside a table in the form of what are the ways in which it cannot be, or it can be constrained and it cannot be there, right? So they are referred to as constraints in the relational data model. Generally, we talk about the three constraints. We'll try to understand each of these constraints before we get into the actual design of the database. We have entity constraint. So the entity constraint says that within a given table, what are the restrictions on the values of those attributes, means column, that you want to put. For example, in the employee table, we said, this is my employee table, we said that there's an employee ID attribute, and there is a name attribute, there is an age attribute. So entity constraint, I want to specify that value of employee ID must not repeat within the table, right? Must not repeat. It will be very inappropriate if I have if I have employees having same employee ID. Can employee ID same? Of course it is not. So it must not repeat within the table, right? So this is a constraint. In the relational data model, we express this particular constraint by saying that this is the attribute, it should be unique, right? It should be unique. So first constraint, unique. We say that this is a uniqueness constant as far as this particular table is concerned, right? So what is worth noting here is that we should be very careful in choosing in which attribute get impacted by this particular constraint. So here in this example, we are saying employee ID is the one which is unique, but it is for two people or two employees to have the same name. So we must not be specifying the uniqueness constant on name attribute. In other words, there are no hard and fast rules imposed by the data model itself saying that what should be made as unique, what should not be made as unique. It is entirely up to your applications to figure that out. On the other hand, instead of employee, if this happened to be a product table, for example, in that case, you might want to say that product ID user is unique and product name is also unique. Uh, Product name is also unique, right? So just because it is a name, it does not mean that it should be always unique, nor does it mean that it should never be unique, right? So depending upon your applications, you have to specify your constraint. You can also see that, for example, age, right? So there can be multiple people having the same age, which is perfectly fine. So you don't need to say anything. So in the design, if you don't specify any constraint, it means that it can take any values. That's why it is called as constraint. Constraint says you bind the values, you limit the values in a certain way. So that is called as uniqueness constraint. Now, I want to make this uniqueness constraint even more a little stricter. What if I want to say that I want employee ID not only to be unique, I also want to ensure that every employee is having an employee ID, right? So you may be wondering what is the difference between these two constraint or these two requirement, right? For ease of understanding, let us assume that we are giving employee IDs based on the serial numbers. So we have employee ID E01, E02, E03, E04, and E05, like that. So on suppose there are 100 employees. So one of the requirement that the uniqueness constraint says that the number that is appearing in that column should never repeat, and it is not necessarily saying it should be 1 to 100, but it has to be unique. But imagine this particular situation. Imagine a situation wherein I am sure all of you are working professionals. So if you are joining a company on day one, when you enter the company with your documents, with your uh, form for joining, you would surprise that your data is all there in their employees table, except your employee ID. Obviously, they don't assign employee ID until you finish the joining formalities. So there is this little gap between assigning this employee ID and where you are about to join, right? So in order to accommodate data into the table, what I will say is as long as the value is assigned, it has to be unique, but it is okay not to be assigned yet. Then we said there are 100 employees already there and 101 first employee working in all my name is there, my age is there, my Aadhaar number is there, all the details are there for employee ID, but employee ID is left vacant for that. They are waiting for me to finish the verification process. So in this situation, we will say employee ID will carry a value, what is known as null, right? So there it can be null. So null value is an acceptable value when columns is having a unique constant, right? I'll tell you something which is slightly counterintuitive there. There's 102nd employee now, right? 102nd employee who is walking in along with your badge. So that employee also will get initially an employee ID of null. Yes or no? Because they are not in a position to complete all the fast, what we can say process for the joining of that particular employee, right? So you may be wondering, right? Oh my God, so we have two people having null values. Is it a violation of my uniqueness constraint? Fortunately, the relational data model is quite safe on that one. It says that it is this uniqueness applies to non-null values. You can have any number of employees with null values. That is still not a violation of the uniqueness constraint as long as the non-null values for that particular columns are unique, right? So null can be anything. Whether there is a uniqueness constraint, you can have multiple null values. That is not a violation of your uh, uniqueness constraint. So multiple null values are allowed. Now suppose I want to put an additional constraint saying that let us go to the product example. In the product example, we have product ID, we have product name. So in there, I want to have a slightly different constraint. I want to say that, you know what it may be in the employee example. It is possible that employee ID cannot exist until they finish the joining formalities. But I don't think product names are like that. When I'm entering information about the product names into my system, I want them to be unique, right? Suppose you have product table. Here we have product ID. We have product name, and we can have its type, something like that, right? So in my product table, we have product ID, we have product name, right? So in that, I want to have a slightly different constraint. I want to say that, that what it may be in the employee example, it is possible that employee ID cannot exist until they finish the joining formalities. But I don't think product names are like that. When I'm entering information about product names into my system, I want them to be unique and I want them to exist, which implies I don't want to take any null values, right? So one way of saying that is the product name must be unique and it should not take null values under the entity constraint. There's a nice shortcut available to say that there's a primary key. When I designate a column as a primary key, what it means is that it has to be unique and it cannot be null, right? So we have one terminology alert over here. We have primary key. It should not, it should be unique and it should not be null. So there are two constraints for that. Forget two nulls, even one null can never be there. So that constraint, so primary key constraint, which is abbreviated as PK constraint, you can think of PK constraint as a special case of unique key constraint, wherein we are putting an additional restriction saying that it has to be unique and it should not be null. So that is your entity integrity constraint for you, right? So you should remember this point in the fashion that I have explained, right? If someone asks you in the interview what is primary key, many of the candidate, what they will do is they'll directly say it is unique and it is not null. It should not be like that. Your interview is always like your storytelling, right? You should have story ready for all of your questions, your own story. So for example, I have just created this story by myself to explain primary key, right? You can take your time, 5 minutes, and you can create your story. You can reframe that by taking 5 minutes, and you can start speaking in front of mirror or start recording videos by just explaining this different kind of questions for your interview, right? So interview, it should not be like it's a random. It should not be like that. If you go to interview, you should rehearse. You should have a rehearsal done for different questions by using your own stories, right? So it should be a flow. It should be in a flow. It should not be in one or two sentence. Answer should always be in the form of story. So there's beautiful saying that they call it as interview just a storytelling, right? It's not different. We are just telling our story, or we are just walking them through with our profile. So for your profile as well, you should have your own story. It should be created, right? For your own qualifications, or for your projects that you have done, for anything, for your education, right? Or for your internship. You should have your own story, your own cassette recorded, and you should just play that when they ask the questions. That's all. Is it clear, guys? Is entity constraint clear for you? Yes. What about other guys? Why I can see only one or two response? Is it not clear for others? Yes. Or is it too? We are just having a theoretical session, so you guys are getting bored. Is that the case? All right. All right then. Okay. So what we are going to discuss now is referential constraint. So in the previous segment, you learn about the first type of constraint, entity constraint, which pertain to the values in a single table. The second type of constraint is called referential constraints. These are used to restrict the values that are taken by a column in one table based on the values that exist in another table. So they are used to restrict the values that are taken by a column in one table based on the values that exist in another table, right? So customer tables are given below. This is your customer table. We have customer ID, we have first name, we have last name, and we have their age. Let us add some more values to look it more alive. Let's see, John Wick. We have Sheldon Cooper, and we have Charlie Harper. So there can be anything. And customer IDs are 1, 2, and 3, right? And we have another table which is order ID. So we'll just write down it over here. So we have orders table in which we have order ID, we have order number, and we have customer ID. Now can you see we are just relating our one table, which is your customers table. We are just trying to establish a relation between customers table and orders table, right? By using this common column customer ID. So 1, 2, 3, 4, and it can be anything 1, 2, 3, 4, 5, 2, and here we have 2, 2, 3, and 1, right? So let us discuss about this now. Many of you guys would have an understanding of foreign key now. We'll just discuss that in more detailed fashion by just plotting a story. So let us now try to understand referential constraint. Referential constraint comes into the play when you want to constrain the values taken by a column in one table. When you want to take a value based on column in one table, so let us highlight that with this color, based on the value that exists in another table. Let us take two tables called employee and department. So the employee has got employee table, has got attributes, employee ID name and department ID. The department table has got department ID and department name. So we can already specify uniqueness constraint as part as the entity constraint. I could have said that employee ID is actually a primary key. For example, if I can guarantee that it will never be null, and then there are no other constraint that I've put so far. If I don't put any other constraint, that what I can do is I can enter whatever values as part of the employees table, and for all the attributes including employee ID name and department ID. Suppose in this particular example that you are seeing, you will see that there are two rows in the employee table. There are two rows E01, E02. Okay, I'll just create a table for you. Just a minute. Okay, what we can do is, let us call it as employee table. That is also fine anyway. Let's keep this. Let us create two table here. So one, this is second table, right? Here the table name is department. We have department ID. We have department name. We have employee ID. We have name. And we have department ID. So we have E01, E02. We have N001, N002. And we have D04, D01. We have D01, D02, D04. And we have finance, HR, and IT. Right? So as you just a minute. The department table has got department ID and the department name. So we can already specify uniqueness constraint as part of my entity constraint. I could have said that employee ID is actually a primary key. For example, if I can guarantee that it will never be null, and then there are no constraint that I have put so far. If I don't put any other constraint, what I can do is I can enter whatever values as part of the employee table. And for all the attributes, including employee ID, name, and department ID, suppose in this particular example that you are seeing, you will see that there are two rows in the employee table. There are two rows E01 and E02. You can see that the department ID that is used in this example is D04 and D01. In general, sometimes what you want to say is that the attribute values of certain columns should not take any value that is permitted. But I want to constrain it in this particular example. I want to ensure that employees are assigned to only those departments that exist, and the department that exists is mentioned in another table called as department table, which says that there are three departments called as D01, D02, and D04, which is finance, HR, and IT, right? So how do you specify this constraint? So this type of constraint is referred to as referential integrity constraint, which means I am putting a constraint on what values as a specific column can take based on the values that already exist in some other table. That is why in this example, let there be any number of employees, all the employees must necessarily belong to those three departments, or in other words, the attribute values. If you look at all the values that are available in the department ID table, it should be one of those three values, right? So that is referred to as referential integrity constraint. Now let me introduce to a new terminology for you. So the attribute which is getting constraint here is referred to as foreign key. In this example, this thing is known as foreign key. Department ID of the employee table, this is known as foreign key. So foreign key, why it is called as foreign key? Because this happens to be a key of some other table. So this is referencing a key of the department table. That is why This is the department ID in the employee table is referred to as foreign key. So whenever we are specifying foreign key, we unlike the primary key or uniqueness key, you can just specify, you can circulate, you can underline it and says this is a primary key. You cannot blindly say that this attribute is an foreign key. What you have to say is department ID of employee is foreign key, which refers the department table, right? We have to be more specific, which references the primary key of the department table. Once you add that constraint, then when you are using that particular database, the database will give you an error when you are trying to insert a row which is having a department ID which is absent in the department table. So if I just write down D03, it will throw me error, right? So this is referred to as a foreign key. So we already talk about unique key, we already talk about primary key, we already talk about foreign key. Now just to confuse you a little bit, let us understand. Let me throw some comparison between these keys to begin with. To begin with, foreign key. It is not a key at all. What is the characteristics of a key? What's your characteristics of a key? That it has to be unique. And you can clearly see here that there can be more than one employee with belonging to the same department. Yes or no? So I can add a new row E03 who works for the same department D01. Yes or no? So foreign key need not necessarily to be unique. Need not necessary really be unique. So foreign key need not necessarily to be unique. We can have additional constant, that is, it has to be unique under circumstances, but this does not mean that foreign key is unique, right? This is difference number one. Difference number one between foreign key and primary key. So I'll just take this here and primary key here. So that is your difference number one. The second one is primary key. Comparing it with primary key for any given table, there can exist only one primary key. There can only exist only one primary key. So you have to make up your mind, what is that single attribute which will never be empty or null and which will always be unique? You have to identify that, right? So for every table, that can be exactly only one primary key. Every table, you have only one primary key, right? Whereas a given table can have any number of foreign keys. If I go back to employee table, I can have another foreign key which talks about the branch to which it belongs to. Suppose we have another thing, branch, right? So that can be a foreign key. That can be a foreign key which references to another table called as branch table, correct? So that is a second difference for you, right? Which means a primary key, there can be only one primary key for a given table, but a table can contain any number of foreign key, in other words, right? Any number of foreign key is possible. What we are saying is a table can reference to many other tables, right? So this is another very important difference, of course, if you compare it with unique key. And single table can have any number of unique keys. You can say name is unique key, you can say mobile number is unique key in that particular table, you can specify any number of unique keys. But as far as the primary key is concerned, there can be only one primary key and any number of foreign key. And one last thing that I want to mention with respect to foreign key is the foreign key says that it has to reference the column of another table, which happens to be a primary key. That alone is not sufficient. The value that I'm actually inserting into the employee table, that department must be existing already in the department table. For example, suppose I'm creating a new department called estate management department. Right? So I know that is going to be a department number 05. It is just stuck in some approval process, but then I have already lined up people to join that particular department. So what I cannot say is, I cannot say that employee number 04 who is joining with this into this company is going to be in department 05. Right? You cannot say that कि वो department आ रहा है, that department is not there, but you can join our organization. Can we say that? We cannot say that, right? Which means we have to, if that is the case, we have to insert the row D05 into department table first before you can designate somebody in that database as belonging to department 05. Which means the foreign key restriction is not only referencing an attribute, but the specific attribute values that are existing at that point in time. So if you really run up and end up in this kind of situation, then you have to manage this piece of information outside of the system only after you get the necessary authorization to insert a row of department 05. You should add the employees belonging to that particular department. Of course, a small workaround I can give you. The small workaround is you can insert initially the employee into that database and put a null value for that specific branch, right? Because D05 does not exist yet, you can initially store it as null value, and so that gives me one difference between primary key and foreign key. Foreign key can be null, primary key can never be null, right? So third difference we have. Foreign key can be null, primary key cannot be null, right? So initially I will put it as, once the department gets created, once that rows gets inserted into the table, then I can go back to that specific employees, and then I can update that employees branch ID to be department 05, so that this is a referential integrity for you, what is implemented using this term called as foreign keys, right? So that is a difference for us. Right? So this is also very, very important difference between primary key and foreign key. Now we can go to the semantic constraint and then we can have a break. So we have semantic constraint. Third type of constraint. Okay. Suppose you work at Tata Motors and are asked to analyze the data on the prices of different car models. The values can range from 2 lakhs to around, let's say, 12 lakhs or even more than that. If you are looking to sell cars to middle class households, now imagine you come across a car model that cost 1 crore. You would need to get rid of this value as it would negatively affect your analysis, right? Now here, of course, we are talking about the middle class household. We are not talking about the business tycoon or business person, but it would obviously affect your analysis if we have this data in our model or in our database, and it will generate misleading insights. How you can ensure such values, also known as outliers, are not present in your data. Let us find that in this segment, right? So semantic constraint is also a very important constraint, where it can be used for Aadhaar number, it can be used for mobile numbers or something like that. So you may be wondering if a table can have any number of unique keys, any number of not null constraint, and any number of foreign keys. And why did we say that there can be only one primary key? Suppose you have a requirement. I also mentioned that primary key is nothing but the values have to be unique and it can never be null, right? Values has to be unique, it can be never null. So if you have more than one attribute for which you want to have the same set of constraints saying that it has to be unique and it has to be not null, does it mean that you have only one column for which you can specify that it has to be unique and not null? That is certainly not the case, right? What I'm trying to say is, I'll repeat this one more time. It can never be null and it is unique, right? So if you have more than one attribute for which you want to have the same set of constraint, saying that it has to be unique, it has to be not null, does it mean that you can have only one column for which you can specify that it has to be unique and not null? That is certainly not the case, right? All we are saying is that DBMS expects only one designated primary key, one designated key which is given that spatial status called as primary key or PK. But every other key for which you want to impose the same set of constraint, that is unique or not null, that can be possible, right? Suppose there is a mobile number right along with the employee ID, right? Suppose we have a mobile number right along with the employee ID. Let's add that. So you want to ensure that not everybody must have a must give their mobile number, and it is not optional, right? It has to be unique. It has to be unique. And it is not optional. Basically, it has to be unique. Mobile numbers cannot be shared. For example, that is a constraint that you want to specify. You can say employee ID is primary key. You can specify similar kind of constraint on mobile number without calling it as primary key, right? So what you say is, you say mobile number is unique and not null. And see, effectively, you have to the impact of a primary key, but the RDBMS does not permit you to give the designation of primary key for more than one attribute. Okay, so hope that clarifies the whole entity constraint and referential constraint. Now let us move to the semantic constraint. Semantic in English means, does anybody have an idea about this? If you just search semantic, anyway, that is fine. If you don't have idea about that, semantic, connected with the meaning of words, right? So semantic in English means meaning. If you want to specify additional constraint on the values that a special attribute can take, this is where you can use semantic constraint. To specify that, for example, most common semantic constraint is very basic data type. You want to say that this is string, or this particular attribute can take numbers. This thing, particular attribute, can take strings. And if it can take numbers, what is the size of that number, right? As you know, mobile number, it has to be 10 digit. So you can put that restriction over there, semantic. What is the maximum length of the string, or what is the minimum length of the string? All this would come under semantic constraint. Incidentally, you can also have a few other constraints saying not null constraints, right? It may not be unique, but you want to ensure that everybody specifies their, I don't know, so there is a gender attribute. You want to ensure that you definitely capture that particular attribute for every employee. So you can specify that gender is not null. So that would constraint that would become a semantic constraint, right? Another example is that we already saw that you can use the notion of a foreign key wherein you want to constrain the set of values to the set of values which appear in some other table. What if I want to constrain based on my own set of values, which is not there in some other tables, this is referred to as enumeration. Suppose I want to say now there's a bank account table and there's account type attribute. There's account type attribute. And only one of these three values it can take. It can either be savings account, or it can current account, or it can investment account. I mean, except this, it is not allowed, right? These are the only three types of account that are permitted now. One way is to create a new table called investments and then have this three rows there and specify it as a foreign key many times. That's an overkill. So if you want to constrain based on a small set of fixed set of values instead of using foreign key, you are better off specifying it as semantic constraint and use the enumeration facility to say that it can take only this set of values. That this is another example of a semantic constraint. Now, depending upon the DBMS that you are using, you will be able to specify many different kinds of semantic constraint. So you should refer to the respective documentation. Refer to respective documentation of your product. Suppose if you are using a Microsoft SQL, you go to their official documentation, or if you are using MySQL Workbench, you go to their official documentation. And look under the constraint section of the documentation. More specifically, for creating one of the tables, when you are creating the tables internal, tell you what are all the options that you have for specifying semantic integrity constraints, right? So this will give you the fair idea about what the semantic constraint is. Now, is it clear for you guys? Is this thing clear?
Yes, people.
Excellent then. All right. We'll have a break now. We'll have a break now. Just a minute. Okay. All right. Let's have a break for now. I'm continuously talking. It's been 95 minutes, right? 90 minutes at least. So let's have a break for 15 minutes today. So it's 10:35. This material is already there. I'm doing it on Google Sheet. So you can directly fetch this online and you can revise what is being discussed till now, right? The one last thing we are going to do is we are going to discuss entity relationship diagrams. And finally, we are going to discuss the star schema, right? Before moving further with the SQL part. There should something already exist. Does it? Okay. All right then. It's 10:35. Let's have a break till 10:50. Okay, all right. All right, so let us discuss about entity relationship diagram, which is known as ERD. So let us now spend some time trying to understand how to go about designing a database. So we have already seen that for designing a database, what we need eventually is a set of tables, the set of columns associated with those tables, and what are the constraints, right? So the entity constraints, referential constraints, and semantic constraints, we have three constraints. Let us now try to understand how do you arrive at them? How do you know that these are the tables that I want? How do you know these are the foreign keys that I need to know? How do you even document it, right? So we are going to be using specific modeling technique called entity relationship diagram, which is also abbreviated as ER diagrams or ER models. So we'll use those concepts to understand how do you represent the database design in the form of pictures and visual icons. So let us again, just like the way we look at the vocabulary and terminology associated with the relational data model, I'll quickly walk you through the terminology associated with the entity relationship model. So the first terminology that we have to be familiar with, call it as entity. To begin with, the entity is nothing but a small piece of information, a small piece of information that you want to track in the database. So let us start working through this particular example. In this particular example, so we can have entities that we want to track, which might be products, right? So there can be a product which is washing machine, is a specific product that I want to track, or there could be a camera as a specific product that I want to track. So washing machine, camera, this all are referred to as entity, right? But then instead of scattering the entities all over my database, I will say let me group those entities together in a single container, and we'll call this as entity type. So we group this in a single custom container. We call it as single entity type. It's a collective name given to bunch of entities, but then you say, okay, what is common between those entities, right? What is holding those entities together? Then we'll have the set of attributes that can be associated with this entity tags. What it means is that if you have 100 entities of a given entity type, or what it means is each of those entities of that entity type will have this set of attributes that are associated with this entity type. What it means is that if you have 100 entities of a given entity type, or what it means, each of those entities of that entity type will have this set of attributes that are associated with, for example, I said product is an entity type. So if you take specific entity called washing machine, then we can say that that will be associated with this attribute called product code, right? So we have a table product in which we have washing machine as the attribute. So washing machine, what is washing machine? That is attribute, right? And for that washing machine, we can say that will be associated with all these attributes called product code or product name or product line or product scale, or it can be product vendor or product description. or quantity in stock, or buy price, that is maximum selling retail price. Okay, so these all are the attributes that are associated with every entity belonging to that entity type. So you can see that in this picture. This is an example of an entity relationship diagram in which we have represented 1, 2, 3, 4, 5, 6, I don't know, I think 8 maybe entity type. Correct? So these are 8 entity type constitutes your database, right? 8 entity type consist of your entire database. So we have an attribute, but for that we have entity type, right? In this database design, we have to be able to say what is the relationship between these entity types. Those relationships are represented using the lines that you see in this particular picture. Those lines are referred to as relationship types. And so relationship type can exist across multiple entity types. Let us take a few examples to understand the notation and understand the meaning that is captured as part of this relationship type. Okay, so relationship types can be expressed using cardinalities, and cardinalities are can be of multiple types, right? So on what it means is on the left hand side and the right hand side there can be multiple cardinalities that are associated. Typically it can be 0 1 or many on 0 to 1 or many on other side. Okay, so let us walk you through some examples to understand how it is represented and what is the interpretation of that. Let us try to understand the relationship exists between the product line and products, right? So what we can do is this is known as an entity attribute, and this is known as entity type, right? And what about the relation now? Relationship. So we have two entities, let's say product and customer name, something like that. So one product is associated with multiple customer name, isn't it? Or one product is associated with only one product ID. Can we have one product and multiple product IDs for the same product? Can we have that? Suppose I have an iPhone 15. So in my database, iPhone 15 has some product ID, right? Suppose that product ID is IP015, like that. So this product, iPhone, it has only one product ID. Can it have another product ID 016, IP06? That is unique, right?
It can't.
Right. So
Yes.
relation is known as 1 to 1. 1 to 1. But on the other hand, one product can have multiple customers, right? One iPhone 15 can be purchased by another multiple customers. Yes or no? So this is known as 1 to many. This is one product, this is many, right? If you are taking it from left to right, if you are taking from right to left, it will be many to one. It will change. Many customer have only one product or many product, basically. That can be the case. If you are taking customer, actually that can be multiple. Let's say you are taking just generalistic product. Let's say product as washing machine. So then it will be many to one, many to one. But if you're taking general product, like all the list of product, so many customer can have many products, right? But if you're just focusing on one washing machine, so it will be many customer to one. So that relation is known as many to one. So likewise, we have many to many, many to one to many, and one to one, right? We have one to many to one, and many to many. That is your relationship. And that is very simple for us. Everybody knows that, right? So that is your classic example, one to many or many to many, like that. So that is just represented in this entity relationship diagram. That's all. As simple as that. So it's not that difficult. Entity relationship diagram in SQL, if you just take a diagram, this is what it look like. Suppose you have this database, okay, in which we have employee table, jobs table, Roy state and title, sales, author, discount, stores, and number of things are there. If you see this line, so it is not joined by a single line. Can you see that? We have arrow, we have slash, double slash, something like that. Can you see that? So that has a representation, that has a meaning associated with that. What it means is this line is known as 1. This is known as 1. I'll come to that point just a minute. And this is known as many. Right? So here, many, this is 1. This is 1, this is many. So for an example, if I want to read this to product and order detail, how it can be if you're taking left to right, product with order details. So obviously, one product can have multiple order details. So 1 to many, right? 1 to many. If you're taking right to left, multiple orders can have one product ID. Yes or no? Or let's say multiple product quantity can have only one supplier. Yes or no? But one supplier can have multiple product quantity. Can you digest this? Yes or no? One supplier ID can have multiple product quantity, but multiple product quantity can have only one supply. If you have to establish a relation between them. Yes or no? On the other hand, if you just take this now, this two, so all are 1. Basically, one order ID has only one headquarters ID, or one branch ID can have only one headquarters ID, or one branch ID can have only one order date, something like that. So this is how you read your table or entity relationship diagram based on this. One very good hint is you have to look. I mean, this has some meaning, right? You might have 0 as well, like this. O means 0. So if you go to any diagram and if you see there is a 0, this is how it is. Yeah. Can you see here we have 0? So 1 to 0, many to 1. If you are taking from left to right, you'll take 1, 2, 0. And if you're taking right to left, many to 1. Right? Many to 1. Is it clear for you? Yes or no?
I have a doubt on what the 0 means. Can you once again repeat it?
0 to many. Okay, let us take some examples now for this. 0 to many or something like that relationship example so that we can understand. See, this is what I was talking about. So this particular line represents the entire story, right? So let us talk about this over here. So this line first represents 1. This represents many. This is 1 and only 1. This is 0 or 1. Or this is 1 or many. And we just connect that 0 or many like that. So example, okay, here we have this. See, one record must be associated with minimum 1 customer. So that is 1 to 1. One record must be associated with minimum 1 customer, and customer can have many orders. Yes or no? So this is many. On the other hand, an order record must have a valid customer and it must not be null. So this, and a customer does not need to have an order to be a customer. Yes or no? So that is 0. What does 0 represents in this
Yes.
thing is customer does not need to have the an order to be a customer, right? So you can consider that as part of your 0. So anyway, I mean, you will not be exactly spending your time reading this, but before actually moving further with the analysis, you guys need to be aware about this. You guys will create an entity relationship diagram by using the database management system, SQL and something like that, which will help you out to read this, so that it has very significant amount of importance given or weightage given by the designer. It is very important. So that's why we designed that. So that is what it is. I think we can. So I would like you to kind of look lots of example of entity relationship diagram notations, but trust me, you'll find anything more than this three or four. You'll not find anything more than this three or four things that we talk about. Basically, this one, these three or four things. This is what I'm talking about. You'll find relationship type which can be of one of these three types. Beyond that, it will not be any more confusing, right? So even though to understand we can go in depth, but apart from this 1, 2, 3, and hardly this 4, apart from this 4, we don't have anything, especially, or apart from this 3, right? So it is not any confusing. It will not be any more confusing for you, right? Now, we'll stop here for the day. I'll just share this link with you. You can read this article to get an idea about the entity relationship diagram. What we are left with is a star schema. But in order to come to the next session, I wanted to give you one task. You need to download your SQL so that we'll not spend more time in downloading that. It is a time consuming task, right? So you'll find you'll find multiple videos for SQL installation. Multiple videos for installation. You can go and select the latest video and you'll be easily able to download this. Very simple. So what you have to do is you have to download MySQL workbench before coming to the next session. Can you guys do this, everyone?
Sure, Vipul.
Okay, great then. All right. So you can download this. And one more thing, as this pops up in my home screen, I wanted to share this video with you. I was watching this video yesterday night. It is very easy. I mean, not easy, it's very interesting. Uh, if you are really interested in the recent trends in machine learning, AI, generative AI, and its boom and its news, the talks about that, you can follow this channel. Everybody knows Stanford Online, right? Here you'll find a very talented pool of people. They'll be explaining this to you. Obviously, this is a little advanced for you, but I want you guys to inculcate this habit of uh, studying by your own and does not necessarily be the complex topic or simple topic, right? So this is something which is very important. You can explore this channel, this one. And second one, if you realize how drastic of a change this is. Course overview of mastering generative AI. Fortunately, or what we can say, it's very good that we can see Indian guy is taking over this prestigious organization, right? He's there. He's actually teaching students worldwide. So I think he's from Microsoft. Yeah. But previously he has worked in several companies like Uber and McKinsey and several Fortune 500 companies, right? So it will be really interesting if you are interested in this generative AI and its stories. You'll find it interesting. But again, if you're not understanding this, you can just watch it for just like you watch any web series out there, right? That will certainly boost your knowledge, right? Anyway, we are going to see this thing, generative AI, at the end of this course. But beforehand, if you just practice and get comfortable with the new technologies and terms associated with that, you'll grasp that very easily whenever we are learning that. Okay, now it's time for a quiz. I'll ask GUI organizer to come in and take over. And again, I think this quiz it will be of SQL. So don't worry, even though if we have not completed the coding part of SQL, you can just appear for that. I'll let as I already have told them that we are still lagging by 2 sessions, so you don't need to worry about the marks and everything, right? But just appear for that. If it is theoretical, then that is good enough for you to get full marks. But if it's practical, don't worry about that. We are going to complete that. It's not that uh, we are taking a quiz and will not touch that topics, right? Rasita is asking very good question actually. Her question is, I'll just read that just a minute. So coming towards that 1 to 0, 0 to many, something like that. Jeez. Examples. It's very vague example, guys. Like you'll not find this 0 to 1 or 0 to many relation as I told in real life. The 0 to 0 to 1 is, for example, a fictional person, entity, person, and marriage. We can put 0 to 1 notation from person to marriage, as they are either not married or they are married, right? So now you would be having this question that if the person is not married, so why the person is there in this table, right? So these two are entirely the different, solely the different entities, right? So when it comes to our example, where we're taking orders and customer, so it's not like suppose you can have this example, no? That is very legitimate. See, suppose we have one customer named ABC. He's there. He has purchased some other products except one product, that is washing machine, right? So if you're trying to establish relation between them, we can have 0, no? This customer is there who has purchased the other product, but who is a part of customer table, but he is not related to this washing machine, right? So that can be an example for your uh, customer. I mean, that can be the reason why he is there in that table, right? But again, as I told, this is very vague. You will not be fine. I mean, actually studying this 0 to 1 or 0 to many relationship in your real world scenarios. You take any example out there in your real world scenario, you will not be able to see that, as they also have given, right, for fictional entities, right? So you only focus on 1 to 1, 1 to many to 1, and many to many. That's all. 4, more than sufficient. Is it clear? Okay, excellent. All right. What about other guys? Any questions? All right, I'll take silence as a no. Meanwhile, if you have any questions, you can write down in the chat. We have very less time left for the quiz, so we can go for that. If you have any questions, you just write down in the chat. We'll discuss that after the quiz. Yeah.
Yeah, hi everyone. Hi people. So yeah, last week we didn't have the quiz because it was festival weekend. So most of the people were on leave. So yeah, again we're back with the quiz. Today we'll be having for SQL. Yeah, same rules. I'll be pasting the link in the chat box. You have to join from your own screen. You don't have to look at the Zoom. You have to look at the tab, that Kahoot tab. So in a few seconds, I'll be just pasting the link. I've pasted the link in the chat box. Please join. This is a basic quiz, as I used to repeat in the last sessions also. This does has nothing to do with your assignments or your marks. This is just for your active recall and active learning. So, if any questions you feel that it is difficult or it is not taught yet, then don't bother. Maybe it will be taught in the next few sessions. Okay, because this quiz is not prepared by Vipul, so he has his different way of teaching. So, this is just a basic quiz. Okay, 14 have joined. Rest, please join soon. We are 26 here. So it's 11:23. 11:25 we'll start the quiz. Okay, so we are starting the quiz. What is data modeling? Great. Which of the following is a common tool used in data modeling? What is the primary purpose of a data model?
Eu mo-
What is normalization in database design? In a star schema, what is the purpose of dimension tables? What does ACID stand for in the context of database? Which ACID property ensures that all transactions occur in isolation from one another? What does DML stand for in SQL? SQL. Okay, so second last question for the week. Which of the following is a DML operation? Last question. Which SQL command is used to retrieve data from a database? So Mr. or Miss, whoever it is, ABCD is third, then Karthik Srinivasan second, and then Rasita is first. Great job, everyone. Okay. So thank you, everyone. We are done with the quiz. Vipul, if you have anything, then you can add, or we can wind it.
Yeah, sure. Thank you. Yes, everyone, do you have any questions related to whatever we have discussed till now?
No, Gopi, no quiz was conducted last week because it was festival weekend. Okay, so the count of attendees was less compared to.
Yeah, actually, Gopi is thinking that this quiz carries some weightage of marks. That's why he's more.
No, Gopi. Like as I mentioned, that this quiz is just for your active recall. It doesn't have any count in your assessments or assignments. Okay, this is just for you. Okay. Whatever the assessments or assignments or the projects you will be getting from our end, that will carry the weightage. Okay. In these live sessions, these daily quizzes don't have that any weightage. Okay, so please don't think that it has some weightage or it will affect your marks.
Okay, then I think they don't have any questions. We can stop.
Sure. Thank you, everyone. Goodbye. Thank you, Vipul.
Yes, thank you guys. Thanks
Thank
everyone.
thank you, Vipul.